Physics tells us that the Big Bang should have produced equal amounts of matter and antimatter. Matter is everything around us, atoms, planets, people. Antimatter is its mirror twin, identical in mass, but opposite in charge. The problem? When the two meet, they annihilate each other instantly, vanishing into pure energy. If matter and antimatter really were created equally, they should have wiped each other out in the universe's first moments. Nothing, no stars, no galaxies, no life should exist. Yet here we are. For every billion antimatter particles, there must have been 1,000,000,001 matter particles. That single surplus particle per billion is what all of reality is built from. Every atom in your body exists because of this tiny, unexplained imbalance. Scientists have smashed particles in accelerators and scanned the skies for hidden antimatter regions, but no answers have emerged. Our existence rests on a fundamental cosmic glitch, a violation of symmetry that shouldn't have happened. The very fact that you're hearing this means the universe bent its own rules for reasons we still cannot explain. The oldest light in the universe, called the cosmic microwave background, or CMB, is a relic from when the cosmos was just 380,000 years old. Normally, it's nearly uniform, with only tiny temperature variations that seeded galaxy formation. But astronomers found something deeply unsettling. An enormous patch of sky, hundreds of millions of light years wide, that's dramatically colder than expected. This cold spot is about 70 to 140 microkelvin colder than its surroundings, far beyond normal statistical fluctuation. The most common explanation is that it's caused by a supervoid, a vast empty region of space-draining energy from light as it passes through. But even the largest supervoids discovered aren't big enough to fully explain it. That leaves darker possibilities. Some cosmologists have proposed that the cold spot is evidence our universe collided with another in the distant past, leaving a scar in the fabric of reality. Others suggest physics itself might be incomplete at cosmic scales. Either way, the cold spot remains an anomaly we can't explain. A bruise on the face of the universe hinting that our cosmos may not be alone. Movies show exploding bodies or instant freezing in space. Reality is stranger. If your suit failed in the vacuum of space, you'd have only 10 to 15 seconds of consciousness before losing oxygen. The air in your lungs would expand violently. Holding your breath would rupture them. Moisture in your eyes, mouth, and lungs would begin to boil. Not from heat, but from lack of pressure. Your body would swell to nearly twice its normal size as gases came out of your blood. You wouldn't pop. Human skin is surprisingly tough, but you drift unconscious within seconds. After about 90 seconds, irreversible brain damage would occur. Astronaut Jim LeBlanc experienced this during a 1966 chamber accident, and his last memory was saliva bubbling on his tongue. In orbit, the Soyuz 11 crew tragically died when their capsule depressurized during re-entry. What disturbs scientists further is not just how swiftly space kills, but the unanswered questions for long-term missions. How do crews handle a dead body on multi-year trips to Mars or beyond? Decomposition behaves unpredictably in microgravity, and no protocol exists for burial in space. The ethics and logistics of death beyond Earth remain unresolved, adding a chilling psychological layer to humanity's push into the cosmos. At scales trillions of times smaller than atoms, space-time itself may not be smooth, but frothing with chaos. Physicists call this quantum foam. Imagine the ocean from high above. It looks calm, but zoom in and you see relentless waves and turbulence. Space works the same way. At the quantum level, it bubbles with virtual particles constantly appearing and vanishing. These microscopic fluctuations may subtly distort light and even challenge the constancy of the speed of photons. Some gamma-ray burst observations hint at tiny irregularities possibly caused by quantum foam. If true, it would mean reality is fundamentally unstable, a flickering, glitching fabric that only averages out to the solid world we perceive. The unsettling implication is that our stable reality is built on seething chaos. Worse, some theorists speculate that if a quantum bubble failed to collapse, it could theoretically expand uncontrollably, swallowing the universe from the inside out. We live in a world balanced precariously atop a boiling foundation, calm only in appearance. Space is not empty. It's filled with micrometeoroids, sand-grain fragments of ancient collisions that travel at 10 kilometers per second. A grain of dust at that speed hits with the energy of a bullet. Astronaut suits and spacecraft shielding can't block them all. A random fleck could puncture equipment or fatally breach a spacesuit without warning. And then, there's human-made debris. Millions of pieces of junk. Old satellites, bolts, paint chips, orbit Earth at speeds up to 28,000 kilometers per hour. Even a screw could destroy a satellite. And worse, collisions generate more debris, triggering a cascading chain reaction called Kessler syndrome, where Earth's orbit could become so cluttered that launching rockets safely becomes impossible for decades. Astronomers already track over 30,000 objects larger than 10 centimeters, but countless smaller fragments remain invisible. Space has become a shooting gallery of invisible bullets, threatening not just astronauts, but the satellites running GPS, communications, and global weather systems that modern civilization depends on. Gamma ray bursts, or GRBs, are the most powerful explosions since the Big Bang. They occur when massive stars collapse or neutron stars collide, releasing beams of gamma radiation across the cosmos. A single GRB can emit more energy in seconds than our sun will in its entire 10 billion year lifetime. What makes them terrifying is that they travel at the speed of light, invisible to human eyes. If Earth were struck by a nearby GRB, there would be no warning. Gamma rays would rip apart our atmosphere, destroying the ozone layer within months. Without this shield, ultraviolet radiation from our sun would scorch Earth, triggering mass extinction. Scientists suspect a GRB may have caused the Ordovician extinction 450 million years ago, wiping out 85% of marine species. While the odds of one hitting Earth are low, it's not impossible. In effect, we live under the crosshairs of undetectable cosmic snipers that could end life instantly and silently. Not all black holes remain tethered at galactic centers. Some become rogue, ejected by galaxy mergers or asymmetric supernova kicks. These dark giants drift invisibly through interstellar space, detectable only when their gravity distorts light from background stars. Astronomers estimate the Milky Way alone may contain 100 million such wanderers. If a rogue black hole passed near our solar system, its immense gravity could disrupt planetary orbits. Earth could be hurled into interstellar space, or nudged toward the sun. Even a distant pass could destabilize the Oort cloud, raining comets inward. The scariest part? We wouldn't see it coming. A rogue black hole is perfectly black against the void. By the time distortions revealed its approach, it might already be too late. These invisible cannonballs, millions of times heavier than our sun, move silently through the galaxy, waiting for chance encounters that could erase entire solar systems without warning. Cosmologists believe the universe's long-term fate is not fiery destruction, but a slow suffocation. Expansion, driven by dark energy, will continue forever. Galaxies will drift apart until they vanish beyond each other's horizons. In the far future, every star will exhaust its fuel, leaving behind only cooling remnants: white dwarfs, neutron stars, and black holes. Eventually, even black holes will evaporate via Hawking radiation. If protons decay, even atoms themselves will dissolve. The universe becomes a uniform soup of stray particles, spread so thinly that interactions cease. This heat death means no energy differences exist to power processes. No stars, no life, no thought. Just eternal darkness, silence, and stillness, barely above absolute zero. Unlike other apocalyptic scenarios, this one is almost certain, backed by our best physics. The cosmos, once vibrant with galaxies and life, will one day become a frozen tomb. There is, however, a more violent possibility. If dark energy grows stronger over time, expansion won't just continue, it will accelerate catastrophically. This is the Big Rip. 60 million years before the end, galaxies themselves would be torn apart. And about 3 months before the final moment, solar systems unravel. Earth would drift into darkness. 30 minutes before the end, planets shatter. In the last instant, the expansion becomes so overwhelming that it rips apart atoms, stripping electrons from nuclei. Even space-time itself would be torn apart. Unlike heat death, which stretches across unimaginable trillions of years, the Big Rip could arrive sooner, depending on the nature of dark energy, which remains one of cosmology's greatest mysteries. In this scenario, the universe doesn't fade away. It self-destructs, erasing matter and the very laws that hold it together. Sound cannot travel in a vacuum. That means space is not just quiet. It's absolutely silent. Even the most violent cosmic explosions produce no audible noise. If a star 10 times larger than our sun exploded beside you, you'd see it, but you'd hear nothing. For astronauts, this silence is not only physical, but psychological. Isolation in space amplifies stress, anxiety, and hallucination. Imagine drifting untethered in orbit, screaming, banging on your helmet, only to realize your voice cannot travel beyond the thin bubble of air inside your suit. Not even a rescuer meters away could hear you. This absence of sound is also an absence of connection. On Earth, sound links us to our surroundings. In space, it dies instantly. The silence is a reminder of cosmic indifference, a void where human senses fail. The most terrifying fact isn't cosmic violence, but the realization that in the grand scale of the universe, even your loudest cry vanishes into nothingness. The universe is filled with forces and phenomena we barely understand. From invisible black holes to death rays we cannot see, to a cosmic silence that erases even the possibility of sound. The most frightening truth may be that we don't know what else is out there. Each discovery raises new questions, and every answer leads to deeper mysteries. Space isn't just vast, it's profoundly unsettling, and scientists are still trying to grasp its most terrifying truths. If you want to keep exploring the universe's strangest mysteries with us, check out this video next. Thanks for watching.